Hi guys, last week we were learning to convert fractions into their decimal equivalents. Because our decimal number system is based on scaling up and down by 10, we were restricted and had to make sure that we first converted the fraction into tenths or hundreds before we could identify its decimal equivalent. So 1/2 can be converted into 5 tenths, and we can then express that as a decimal as 0.5. This week we're learning to solve problems using percentages. But before we can do that, we need to fully understand what this word percent means. Let's get thinking, and that's exactly what I want you to do. I want you to discuss what this word percent actually means. So discuss this with a partner, justify your thinking by giving reasons, and then share your thoughts with the rest of the class. Let's split that word percent into its two syllables. We've got per and cent. Now, per means for every or out of. For example, 3 out of every 5 children were boys, or we could say 3/5 of the children were boys. And cent means 100, like 100 cents in a dollar, or as a prefix in words like century, which means 100 years. If you look at that percentage sign, you can see that it's actually in the form of a fraction made up of the digits 1 and 2 zeros. So a percentage is another way to represent a fraction, and it's even more restrictive than the decimal equivalent because it has to be expressed out of 100. Next, I'd like you to have a look at this bar, and I'd like you to discuss what fraction of this bar has been shaded. Now, once you've done that, I want you to have a think about how many different ways you can express that. Can you find equivalent fractions? Can you express it as a decimal? So pause the video for a couple of minutes, discuss that with a partner, and then share your thoughts with the rest of the class. We can see that this bar has been split up into 100 parts, so each of those parts is 100th, and we've shaded 24 of those parts, so we've got 24 hundredths that are shaded. So we can say that 24 hundredths have been shaded, and we can express that using decimal notation like so. We can use our understanding of equivalence in order to find equivalent fractions. Instead of splitting that bar into 100 parts, we could combine every 2 parts, which means we could create 50ths. And 12 of those 50ths would be the same as 24 hundredths. And we can simplify that again. This time we can combine every 4 of those parts, and we've created 25ths. And 6 of those 25ths would be the same as those 24 hundredths. Let's go back to our 24 hundredths, and we know that a fraction means out of. So we've got 24 parts are shaded blue out of 100 parts altogether. But we now know that that word percent means out of. So we can now express that as a percentage. 24 out of 100 is 24 hundredths, and we can write that as 24%. Now I'd like you to have a go at converting each of the following fractions to a percentage. We've got 2/5, 13 20ths, and 28 35ths. So pause the video for a few minutes, discuss that with a partner, and then share your thoughts with the rest of the class. Let's have a look at 2/5 to begin with. We can find an equivalent fraction in hundredths. Each of those fifths can be split into 20 parts. We've created hundredths, and 40 of those hundredths is exactly the same as 2/5. Now that we've converted it into hundreds, we can then express that as a percentage. We've got 40 out of 100, and we know that that means 40%, which we can also write using the sign. Next, we've got 13 20ths. Again, we're going to have to convert this into hundredths before we can express it as a percentage. Each of those 20ths can be split into 5 parts. Now that we've done that, we can see that 65 of those hundredths is the same as 13 20ths, and we know that 65 hundredths means 65 out of 100, so we can now express that as a percentage, which is 65%. Now the last one is trickier. We've got 28 35ths, and I can't convert 35ths into hundredths. However, what I can do is I can simplify that fraction to begin with. I can see that 28 35ths is exactly the same as 4/5. All I've done is combined 7 parts at a time. Now that I've converted that into 4/5, I can find an equivalent out of 100. We can split each of those fifths into 20 parts. We've created hundredths, and you can see that 80 of those hundredths is exactly the same as the 4/5 and the 28 35ths. Now that we've done that, we can once again say we've got 80 out of 100, which we can express as a percentage, and that's 80%. Previously, we've developed an understanding of finding a fraction of a value. Now that we know that a percentage is actually a fraction expressed out of 100, we can find a percentage of a value. So I'd like you to have a look at the following 3 problems, have a go at analysing and solving these with a partner, and then share your thoughts with the rest of the class. 30% of the fans at a football match support Brazil. There are 120 fans at the match altogether. How many Brazil fans are at the match? The second question, 75% of the children who go to swimming club are girls. How many girls go to the club if there are 152 children altogether? And then the third problem, 40% of the children who go to film club are boys. There are 60 boys in the club. How many children go to the club? Pause the video for 8 to 10 minutes and have a go at those. Let's have a look at that first problem. 30% of the fans at a football match support Brazil. There are 120 fans at the match altogether. How many Brazil fans are at the match? Let's start by drawing a bar to represent the whole amount. And in this case, that whole amount is the total number of fans at the match. Now we're dealing with a percentage. We've got 30%. So I could split that bar into 100 parts and look at 30 of those parts. But I don't need to do that. I can use my understanding of equivalence to split that bar into fewer parts. I know that 30% is 30 hundredths, but I can use my understanding of equivalence to work out that that's 3/10. So this time, rather than splitting the bar into 100 parts, let's split it into 10 parts, and each of those parts is worth 10%. Now that I've done that, I can identify that 3 of those parts are the Brazil fans, and that's 30%, and 7 of those parts represent the Argentina fans, and that's 70%. So the bar that we've got here is exactly the same as the bars that we used when we were working out a fraction of a value. Now that we've done that, we can put in the value that we know. We know there are 120 fans altogether at the game, but we don't know how many are Brazil fans and how many are Argentina fans. Now that I've analysed it, I can solve it. I can see that those 120 fans need to be split evenly between 10 parts. Let's use our base 10 materials to help us. I can begin by putting 10 in each of those parts. So that's me shared out 100 of the 120 fans. I've got 20 left, so I can put another 2 in each part. That's me shared out my 100, then my 20. I've shared out all the fans, so I can see that each of those parts represents 12 fans. So 10% of the 120 fans is 12 fans. But we're interested in how many fans support Brazil. We know that's 30%, so we've got 3 lots of those 12 fans, which gives us 36 Brazil fans, and we can also work out that there are 84 Argentina fans at the match. Let's have a look at that second problem. 75% of the children who go to swimming club are girls. How many girls go to the club if there are 152 children altogether? Once again, we've got a percentage. We've got 75 out of 100, so I'm going to start by drawing my bar to represent the whole amount, and here that whole amount represents the total number of children in the swimming club. How many parts am I going to split that bar into? I'm interested in 75 hundredths. Does that mean I need to split the bar into 100 parts? Well, I could, but I can use my understanding of equivalence, and I can simplify 75 hundredths to 3/4. So rather than splitting the bar into 100 parts, I can split that bar into 4 parts. Now I know that 75% of the children who go to the club are girls, so I can identify those 3 parts there, which means that 25% of the club are boys, which is that 1 part there. Now that I've done that, I can put in the value we know. Once again, it's the whole amount we know. We know there are 152 children altogether. So I can see that what I need to do here is share those 152 children between those 4 parts, which each represent 25% of the club. Let's use our base 10 materials again. Once again, I can see that I've got enough to put 30 in each of those parts, which means I've shared out 120 of the children. I've got 32 children left, which means I can put 8 children in each of those parts. That's all of the 152 children shared out. So I can see that each of those parts, which is a quarter of the club or 25% of the club, is worth 38. The girls make up 3/4 of the club or 75% of the club, which means we've got 3 lots of 38, which gives us 114 girls. And I can also identify those 38 boys that are in the club. Let's discuss that final problem. 40% of the children who go to film club are boys. There are 60 boys in the club. How many children go to the club? Once again, let's draw a bar to represent the whole amount, and in this case, the whole amount is the total number of children that go to the film club. We know that 40% of the children are boys, so we've got 40 hundredths, but that can be simplified to 4 tenths, which means that I can split this bar into 10 parts. 40% of the children are boys, so 4 tenths of the children are boys, so we can identify that like so, which means that 60% of the children are girls, which is represented by those 6 parts. Once again, we've split that bar into 10 parts, and each of those parts is worth 10%. Now that we've done that, we can put the value in that we know. Now this time, it's not the total children that we know. This time we're told that there are 60 boys. And what we're trying to work out is the total number of children. So in order to solve this, I'm not sharing out the 60 equally between the whole number of parts. We know that those 60 boys is only represented by those 4 parts. So this time we're going to divide 60 by 4. I can start by putting 10 in each, which means I've shared out 40. I've got 20 left, so we can put another 5 in each. So each of those tenths or 10% represents 15 children. Now if we know that each of those 10% represent 15 children, we can put 15 children in each of the other parts. So I can work out the number of girls, which is 6 lots of 15, so there are 90 girls, and altogether we've got 150 children. It's time to discuss our success criteria. How did we achieve success? What are the steps that we need to go through in order to solve problems involving percentages? Pause the video for a few minutes, discuss that with a partner, and then share your thoughts with the rest of the class. When we want to solve problems involving percentages, the first thing we can do is draw a bar to represent that whole amount. Once we've done that, we can describe that whole amount, and that whole amount is always 100%. Once we've done that, we can decide how many parts, and we can use our understanding of equivalence to decide how many parts to split that bar into. When we were solving the problem involving the football game, we knew that we were interested in 30%. So we split that bar into 10 parts, where each of those parts represented 10%. The next thing we can do is then describe the parts and their percentages. We knew that 30% of the fans were Brazil fans, and we could work out that 70% of the total fans supported Argentina. The last thing we can do when analysing this problem is write the value we know. In this case, we knew the whole amount of fans was 120, so we could put that there, and the unknowns here was the number of Brazil fans and the number of Argentina fans. Now that we've analysed that, we can choose a strategy and solve it. And in this case, we decided to divide that 120 by 10. We worked out that every 10% was worth 12 fans, which meant we had 36 Brazil fans and 84 Argentina fans at the match. It's time to try that out. Can we apply that success criteria in order to analyse and solve the following 3 problems? As ever, I've got 3 sets of numbers, and I want you to choose the values that are best suited to you. So for question 1, I'm going to use the yellow value. Lucy has £80. She spends 30% of her money on a concert ticket. How much was the ticket? Question 2, I'm going to use the green value. Tom bakes 180 biscuits altogether for his mum's birthday party. 20% of the biscuits are gingerbread men. The rest are bells. How many gingerbread men did Tom bake her? And for the third question, I'm going to use the red value. 40% of the fans at a rugby match support Scotland. There are 260 Scotland fans at the match. how many fans are at the match altogether? If you manage each of those in the time, why don't you make up 3 problems for somebody else to analyse and solve? So draw bars to help you analyse these problems and use resources in order to help you solve them. Pause the video for 10 minutes or so and have a go at those. It's time to reflect in today's learning. So with a partner or as a class, I'd like to consider the following questions. What have you learned today? What did you find easy or difficult? Did you get stuck? What helped you when something got tricky? What do you need more help with? What is really making you think? And what are your next steps? The last thing I'm going to ask us to do today is, can we apply what we've learned? So as a class, I'd like to discuss, analyse and solve the following problem. Michael pays £105 for a pair of trainers in the sales. The trainers had a discount of 40%. What was the original cost of the trainers? Thanks for joining me again today. I hope you enjoyed that. As ever, if you want to share your solutions or if you've got any questions, you can contact me at scott.morrow@southayrshire.gov.uk, or you can follow me on Twitter @ScottMorrowSA, where you'll be able to access my weekly Friday Maths Challenge. Next time we're going to be looking at problems involving ratios. I hope you can join me then.